Hi all. Welcome everyone. First of all, thanks for your time for taking time to attend a presentation on IoT Hub, and thanks Weber for providing an opportunity to speak at a forum like this. So today's topic is something that we all know. We all have been like using it in our day-to-day lives, and I mean, in the past few years, it has become one of the oft-used products, which we just use it just like any other shirt or pant that we wear. So uh, let's first start by looking at what is it that we can expect out of the session and then go into what the session is about. So at the end of this session, the expectation is that we would have a clear understanding of the basics of IoT Hub, the features it offers, and how do we like do the basics of provision an IoT Hub on Azure, and how do we provision devices on IoT Hub, and how do we integrate to some Azure services, and one major feature that is like most used in IoT Hub is the message routing. So we would be able to see what that is about. And we would be looking at or getting a basic knowledge on some of the advanced capabilities of IoT Hub, like IoT Edge. So at the end of this, it is not that we would be able to master IoT Hub or the internals of IoT Hub in any sense. We scratch the surface of it, delve into the major features that would equip us to have a decent to good conversation with anybody on a discussion room, and enable or position us to be able to use IoT Hub to solution stuff or the challenges that we face. That's the expectation or goal of this session. Just wanted to be clear and set that up front. Going into the agenda, I don't want to go through this list one by one, but pretty much we are going to start from the introduction to some of the demos. The demos are going to be scattered along the way, not at like towards the end or anything like that. We will take a topic, talk about it, look a demo at it, take a topic, talk about it, and look at a demo. And at the end of it, we can see some best practices that probably actually I had learned over the years as we had been using it in some of our projects. And like it works at scale for like 1 million messages a day, which potentially the potential plan is to scale it to 3 million in the next 8 weeks and then like go from there. So first, to begin with, just as we were talking about, like, what exactly is IoT? Very simply put, anything that can, any two physical devices that can talk to each other and to a centralized place, that is IoT. There are various great definitions out there, but I'm just trying to remember it in its most simplest forms. Any two devices that can connect and talk to each other or to a centralized server. That is basically a thing that is connected to the internet. That's it. So now the second question that I always have about is, there are a lot of flavors of these technologies. All these do come, like when it becomes relevant and when it becomes important. For example, we are still at the brink of the IoT. It is not that we have matured. The IoT is not matured like, let's say, a web application or a mobile application. Today, mobile apps are like much more matured, right? So IoT is something that we are just starting, but it is becoming very pervasive, very important. And why it is? Basically, for any technology to succeed, the infrastructure has to be there for it to succeed. The web application started succeeding once the internet infrastructure took shape. The mobile application started succeeding once the mobile touch OS, smartphones, and all that came into picture. Similarly, for the IoT, as we just discussed, because it relies on devices, connectivity, and the ability of the devices to speak to each other, with the advancement of sensors, better mobile growth, better mobile connectivity, and all that, that has paved the way for the IoT to kind of succeed and become more pervasive. And the next question leads to, all right, this is IoT. I understand why it is important, but how is it that, what are the ways in which it can help us grow? In reality, there are plethora of ways that has already been explored, but I believe there will be many more ways that would come as we go through. Some of the basic ways in which the IoT is used to, one, provide user convenience. On the other end, for the businesses to be able to optimize their workflows, get data, and derive meaningful analysis out of the raw data, which enables them to perform operational and organizational transformations. So these these transformations typically end up in either improving efficiency, productivity, customer experience, or cost cutting. At the end of the day, it boils down to any of the four facets which would directly impact the economics of the organization. So that is the reason why IoT is becoming big. If we are good with this, we can go to look at what are the challenges of IoT, right? Like any technology that comes in or any of these component that comes in, the first thing that is going to be there are a lot of advantages, but all these advantages always come with a set of challenges, a set of baggages. So if we want to look at, there are a lot of challenges. I've tried to summarize it into quite a few. One, as we said, it is device. It is a physical object that can be anywhere in the world. So connectivity is going to be a challenge. When we say connectivity, connectivity to a centralized place is a challenge, and having a long-lived connectivity, that in itself is a challenge. And there are going to be very remote places where you might not have internet connectivity at all. That is also going to be a challenge. Two, security and privacy. Now, once we have devices and once we have devices at a specific place, the most basic data that you could get out of it is where the device is located. That's security, because that's going to get a hacker to know where a device is or where the suite of devices is. For example, if I could get the IP of your home's thermostat, I know where you live, right? So the security becomes an important component when we deal with IoT, because the security in turn can directly affect your privacy, as we saw in the example of a home's thermostat getting compromised. That is one of the most major challenges, because by breaching that security and by invading your privacy, imagine me taking control of your home's thermostat, right? So we can have a, what do you call, January in July by just adjusting your thermostat. So that's the reason why security has got to be or play such a big role. The third one is about interoperability. Interoperability is a well-known problem even in the mobile world, especially on the Android world. iPhones are great. Like, there is very little challenge with interoperability. They make the hardware, they make the software. But with Android, you have these problems because the software is made and the hardware is made by all different vendors, and there are always challenges with it. Now, with one platform, when you have the challenge, think about a place where these devices can be manufactured by any manufacturer. And each manufacturer or creator of these IoT devices more or less will have their own standards and protocols to speak with, which would optimize, or the protocol would be optimized for their devices to communicate, right? So if you want devices from one manufacturer to speak with the other, there are going to be some challenges. Typically on the web world at one point in time, just as how you had a challenge before XML or JSON become a format. That's the challenge with interoperability related to the IoT devices. And next is the problem of scalability. What we mean by scalability is, like, typically our mind goes to scalability is number of requests, increase in the number of requests. It is pretty much the same, except for the fact that the scalability here is going to happen with the number of devices or the reporting of the devices, which increases the complexity. Because when you increase the number of devices, the scalability also impacts connectivity. And when you increase the number of or frequency of the devices, that in turn also impacts connectivity because of the intermittent nature of connection of IoT devices. So the problem of scalability is the same as in any other form of web or mobile request, but it is a bit more compounded because of the other challenges that comes with IoT. And in terms of complexity, one of the complexity is like there are places where you would have to do immediate responses back, right? You will have with IoT devices, your situations are going to be where you need immediate response. For example, you have a thermostat, you set it to a temperature, and the thermostat happily says, yep, this temperature would be set in 15 minutes from now. Nobody's going to buy that, right? Or you set a control level for the thermostat, and then the temperature goes above the control level. And then it says, yeah, we'll bring it back, or we'll start cooling it down to your temperature after 30 minutes. We are not going to buy that. We need immediate addressal of it, immediate addressal of such situations. But with a device which has such a small computing power and all that, how do you address that? How do you address these immediate necessities? That is one of the complexity that Internet of Things produce, because this has to be small enough that because of which you cannot put in a lot of computing power into it, but still it has to make decisions which might require a lot of computing power. And data management, very simple. Don't want to spend too much time on the next two items. Data management is important or becomes a challenge because of just the volume of data. Very simply put, there are other details like that data security and all that, but at its most simplistic form, because we are talking about devices, the data management is going to be an issue, because we are talking about something like your electricity. How much of an electricity runs through a wire on a day? It's enormous, right? Because it's going to be there 24/7, running on and on and on, and it's going to generate or pass through that much of electricity. The same is the case of data in terms of IoT. It's going to be there 24/7. It might keep sending readings or data, telemetry data to the servers every 5 minutes, 30 seconds, however that the manufacturer wishes to configure. So, I mean, to just give it in terms of numbers, we from Valmont are into agriculture business, and we have some of these IoT related solutions, and our devices. And in terms of our devices, on a day, we process somewhere close to 5 million to 6 million messages, which accounts to 80 to 100 of those per second or per minute. And this is when the frequency is at 30 minutes. It is set at 30 minutes. So imagine if in 30 minutes once it sends out a telemetry data. So the devices on the field sends out the telemetry data to the server 30 minutes once. So imagine if we just reduce it to like 5 minutes, right? So the 5 million becomes 25 million right by the one single change. So the volume of data is huge. So managing, processing, saving this data is also going to be challenging. But if we are not going to do that, there is no point in collecting that data and leveraging IoT for it. So we should have ways to be able to do that. The last thing is standards and regulations. Just because we saw about interoperability and we saw about security and privacy, you need to have standards, you need to have compliances, you need to have regulations. And since IoT is budding, there are a few places where we have these standards and regulations that are coming in, but there are more that are to be done, expected, and will be done in the future as it evolves. So now on summary, we have looked at the major challenges with IoT. Now let's look about what IoT Hub is, and then let's see whether IoT Hub is able to address these challenges, or have they actually catered to these challenges, right? So in its essence, IoT Hub is basically a cloud-based service which will help you for managing, provisioning, connecting, securing, and doing all these different stuff for the devices. Now, the important the important point of anything is basically the communication aspect of it. You want to be able to talk to it and you want the other thing to be able to talk to it. It can be unidirectional, all bidirectional, but you have to support all those things. So IoT Hub is able to act as a bridge in that essence, trying to tackle all the different complexities. To the left, you can see a diagram. I would just try to touch about it because we would go and see that in detail as we go through it. So to the leftmost, you see a bunch of devices or the different devices which can communicate to an edge device. We will see what an Azure edge device is, and via that to an IoT hub, or it can directly communicate to an IoT hub. Now, the IoT hub, you can see there is just one IoT hub, but there are multiple items that are depicted here. We can see as we go through how these are interconnected and why these are all considered to be part of the IoT solution, right? So that's the place. Those are the means by which I actually ingest data, provision device and ingest data. And once I get the data, there are typically three things that I would want to do whenever I get a data, right? Even in any of our applications or use cases, you would want to perform something on the data immediately and derive a result, or you want to send it off to a place from where a calculation would be done and immediate, and then it would be responded. So the place where you want to do it immediately as is, that is called a hot path. So this is more of Azure's ecosystem where services that can enable you to run real-time processing on it are basically captured here, where that could be the hot path, and services where you could store data and run explorations on it. That's basically the warm path. The third one is the place where you want to accumulate data over time and then run algorithms over it. You are not processing it immediately. You are using that to train your AI models or generate better AI models out of it. That's going to be your cold path. But you can see from all these different paths, you can integrate to a bunch of Azure solutions. I don't want to go into each one of this, but you can just see that how the power that we could leverage by all these combinations. We would touch upon a couple of combinations as we go through the presentation, but the biggest advantage is there are a wide variety of IoT solutions similar to IoT Hub that are available. It's the ecosystem that comes along with it that provides you that extra power, which allows you to do things quickly with a lesser turnaround time, as opposed to taking something else and trying to work with it, right? So any questions till now?
Can you describe the warm path again?
Sure. So the warm path is where you want to take the data and you want to process it, but it need not be real time. And it is not that you actually just store the data and then use it for some other purposes. It's a place wherein you get the data and then you immediately do a quick processing and send it back. Let me talk with the use case, right? Imagine your thermostat, right? You set a temperature. I know in reality it will be done in the local place, but imagine the situation wherein you set a temperature and then the sensor at your home keeps monitoring the temperature and your temperature crosses the threshold. Imagine the set temperature is saved in a server. And the fact that this temperature has crossed is sent as a device telemetry to your server. Now you want to analyze these two, right? You want to analyze these two. Actually, not a great scenario, but imagine that you want to analyze these two and just send an alert to the user rather than correcting it, right? If I want to analyze these two and immediately correct it, that will be my hot path. But if I want to analyze these and just send an information, hey, okay, in the same thermostat, let's say your sensor room connection is not detected. That's your warm path, right? Sorry, I was thinking through that as I was telling, so I was not able to get that scenario right. So
Thank you.
A hard path use case would be correcting it, and a warm path use case would be just alerting. And the cold path is pretty straightforward. Put the data in a cold storage and then use it for anything
I
else.
don't know about your next slide, sorry. Go ahead.
Oh, so middle is still considered the alerting then for use case?
Sorry, what is that?
Alerting the user would still be considered the warm path then, or no?
Yes, it can be
Okay.
considered as the warm.
I don't know what you are going to cover in next few slides, but how does IoT Hub works exactly? Is it plug and play? It seems to be so critical in that process.
Right.
Because all your devices have to hook it up to IoT Hub to enable all the integrations. Unless you cannot hook up to your IoT Hub, you cannot really go to your hot path, warm path, or
Yep.
cold path. So maybe you might have content on your next following slides on that.
Yes.
But it would be really interesting to know how it is pluggable in any scenario. Let's say I have a sensor, temperature sensor that I want to hook up to my.
Right.
So I have never worked with it, but maybe how
We would-
it is, how difficult it is.
Yep, we would see it in the demos. We would be looking at a very simplistic explanation. Actually, if time permits, after the thank you slide, I have 2 slides in detail about how the devices can auto provision. But I had put it after the thank you slide because I don't know whether we would be able to cover that within this 90 minutes. But at its simplistic state, I would still be in the demo, we would still be able to see how we can have a device connect to it in its simplistic state and work with the IoT Hub. But one part you are absolutely spot on. We have to be able to connect with the IoT Hub to leverage any of these other parts, right? And actually, it's an interesting question because that will also answer how these device provisioning service, etc., plays along with IoT Hub. Right? So,
Because looking at the name of that service, I assume that device provisioning service, every time I bring in a new device, I have to provision it with that service so that my IoT Hub can.
correct.
I might be wrong.
No, you are right. You are right. And that the great thing about the ecosystem is these are all plug and play with each other. You just have to provision this once and then it takes care of
And
it.
those two are different services or device provisioning services part of IoT?
It's actually a separate service on the portal. You have to provision that separately, but you link it to the IoT Hub.
So it's a separate resource that we create.
Yes, it's a separate resource that you create. But digital twin, Azure digital twin is something that you can create as a separate resource, or in the IoT Hub, in the device provisioning service itself, you can tell whenever I create a device, do I want to create a digital twin or not? We will actually look through that. So let's look at the major features of IoT Hub. So this slide is basically to explain the major features of IoT Hub and what are the challenges that each of this address. So at the end of the day, we want to tick all those boxes, right? All those challenges boxes that we said, or at least see which of those boxes is not getting ticked. So that's the purpose of this slide. So Azure IoT manages connectivity. It provides features for device management and device twins. We will see how device twins actually addresses the complexity as well as we go through. It provides integration with Azure services. We saw that in the previous slide. It provides a feature of message routing. We would talk about it with a use case as we go to the slide about message routing. And it takes care of a number of security and authentication related scenarios. Meaning it takes care of security in terms of the device connectivity and in terms of the data being securely transferred to its integratable Azure services. And it provides you the ability to do edge computing. And as you can see, since it is a PaaS service, the scalability is not a problem. You would be able to scale it to higher numbers just by click of buttons. And there are options by which you can increase performance, meaning they provide different ways in which the performance could be enhanced. Like it's always a trade-off cost, right? Reliability versus performance, asynchronous versus synchronous. That same game is what being played there. And at the end of all this, as a developer, the one thing that I am always interested in is, hey, will I be able to monitor? How will I be able to monitor and have diagnostics on this so that one, I would have to be alerted when something happens, or two, if I have an issue, I should be able to go look at my logs and debug. So we would look about all those features as we go through the next slides. So I don't want to again get into what this definition is. I've just put it so whenever somebody downloads it and reads, you would be able to do it. But it is basically enabling the device and the cloud to speak to each other. How it does this is more interesting. At one point in time, before the advent of, let's call it the new protocols, TCP was famous, but then TCP was also famous for its lack of speed because it's a request response model. So there had been IoT solutions even before the advent of IoT Hub or these protocols. There are people or there are solutions, even in our own organization, there are a lot of solutions where we use UDP to actually do the communication. But of late, with the advent of protocols like MQTT and AMQP, it has grown manyfold, meaning these protocols give you advantages in size, in terms of size, and in terms of security. So IoT Hub at its basic level supports these three major protocols: MQTT, AMQP, and HTTPS, both 1 and 2 actually. But there is one caveat. I would just mention it. I'm not going to go into detail about it. MQTT has a spec. There are, for example, that spec says 10 rules that are to be satisfied for you to call something as a pure MQTT solution. IoT Hub would satisfy only 7 out of 10. That's their claim. They aren't tackling everything on the MQTT spec. They are only adhering to those specs that are related for communication. And that's it. So, and the IoT Hub will be able to take care of connection security, meaning you need to have an HTTPS connection to it, and you need to have, there are encryption keys, there are X509 certificates, there are all that come into play to authorize or for a device to be able to get connected to the IoT Hub. Meaning, I just cannot put any device as is, and just because I know the IoT Hub's endpoint, I just cannot get connected to it. In its base level, that's what that connection security is. You need something more. That something more can be a symmetric key, can be a X509 certificate from Microsoft, from ourselves. It can be anything, but you just cannot put anything and connect to it. It takes care of device to cloud communication and cloud to device communication. The device to cloud communication is actually much more simpler, right? Like the probability of downtime of your server is always going to be lesser. Only thing might be ingestion. If there are 1 million devices reporting at the same time, I might not be able to ingest it at a speed, so I need to put it into a queue and then ingest it. But that's actually much more simpler. The real complexity comes in terms of cloud to device communication, because devices are known or are expected to be intermittent, to be shut down, to not be available. Simplest use case. Let's say you have a device on your field that runs on solar power, right? You wouldn't want that device to keep running always. Like if let's say that the device is going to report its telemetry once in an hour, then when I'm designing that device, I wouldn't actually have it running always because I want to conserve my solar power that I'm using for the device. So I would send a telemetry and then I'll go to sleep. The next time when I want to send, that's when I will actually come alive, right? So the probability of devices that are going to be sleeping or idle is going to be higher. So the cloud to device is a much more interesting challenge. And there are some constraints that are there even with the IoT Hub because of these challenges. We would just touch upon it when we go through it. Last but not least, it also enables the device connectivity, edge connectivity. We would see what Azure IoT Edge is when we go through to that slide. That will give us better details. Right. So any questions on device connectivity? Okay. Device management. I would run through this fast for a bunch of other things except for device twins. Device provisioning, we know, we just saw. It's basically provisioning that device. device monitoring is you look at the telemetry, and along with the telemetry data, you can also get the device health and some of the metadata of the device, that is monitoring of the device health. Device commands basically means your ability to send something to the device so that the device can act on it. It's basically the C2D communication, wherein you send something to the device and the device acts on it. And the entire lifecycle management. But the interesting facet is about the device twin. In its very simplistic form, think of device twin to be like a service proxy. You do something on the proxy that gets reflected onto the other end, right? Imagine that you have a proxy of the device on the cloud, meaning I want to do a change on the device, do a small update on the device, and the device is not available, right? But when if I'm working with one device, I don't care. I can again come and update it. But if I'm going to update or do things at bulk with like 1,000 devices at once, I cannot keep checking whether each of these devices is available or not for me to do the update and everything. Rather, imagine that you have 1,000 proxies available on your cloud and you just update your cloud and that's it. You are done. The cloud or the device twin then takes care of ensuring that the actual device, when and if it comes alive, the state of that is matching with the state that you have here, right? That's the beauty of device twin. It's like having a device near you that is always connected, do activity on it, even though the actual device is not connected, you do an activity on the proxy and you are good. There are systems that would take care of getting this change reliably communicated over and impacted on the device. That's the great advantage of device twin, and that's why it kind of helps us in the bulk management. With even for other use cases, you can use it, but one critical use case where the device twin comes into picture or was brought into picture was to enable us to perform this bulk management.
Isn't it? It's the same thing as digital twin.
It's actually the same. It's exactly the same. So we will look at now we saw about what the IoT Hub is, how we would connect to it and how we would provision to it. Let's look at how, like, we saw various things at which we were able to integrate to it, right? But let's also see among those integration services, we have tried to categorize that as like into three major categories. One, a way for me to get the data. Of course, Azure IoT Hub kind of gets it, but from the it need not be directly Azure IoT Hub. Within the IoT Hub is basically an event hub or a service bus that kind of gets it, right? So that forms our ingestion. In the ingestion, when the data comes in, I can stream that directly into a stream analytics or event hub. Thereby, they are categorized as data ingestion tools for the IoT Hub. And once I get the data, the next thing is about being able to process the data. And the three that we see here are, or at least the two Azure functions and Azure logic apps are like, for now, it has become like ancient time immemorial things that are dealt with for data processing. Anytime you want to process something on an event-based scenario, you typically end up with just either a logic app or a function app, depending on your use case. And this data, after being processed, either it is sent back, but at the same time, the data that has been ingested has also got to be stored somewhere so that you can run operations on it, derive meaningful insights from it. And those tools where IoT Hub directly integrates to be able to perform data storage is basically the Azure Storage and Azure Time Series insights. The point to be noted is these are all the different tools with which Azure IoT Hub has a direct integration or a tie-in into it. It's not that you need to go through some other hop and then get to Azure Event Hubs. Right from the IoT Hub, I can directly configure an endpoint to tell, hey, my endpoint is actually going to be a event hub. Right from the IoT Hub, I can actually tell, hey, my endpoint is actually going to be an event storage. Right? By default, it has a built-in endpoint of a service bus. But these are all other tools that are directly pluggable from IoT Hub. That's the power. I mean, using these, we would all have done it in various use cases at various places. So using these is not a big, great trick. The trick is in having that power for IoT Hub to directly connect to it and we having the power to configure it to directly go. So you don't have to write any code for these integrations to work. It's out of the box. So before we get to the demo, for one final time, let's look at the device provisioning service. And there is one more before we go to the demo. So it's a fully managed service that enables you to register the devices to IoT Hub. Right? You can you can have that to like you can have it to provision manually using device provisioning service. You would be able to also manually provision using IoT Hub. You can directly manually provision devices as well. But if you want automated or remote provisioning abilities, that is where device provisioning service comes into picture. What I mean by that is I can go to portal and I can click and create a device manually on the Azure IoT Hub directly. But if I want, but that could be just used for a, what do you call, a POC, right? In reality, if I want devices to be able to provision themselves with security and flexible enough for them to be able to communicate to that, that is where device provisioning service comes into picture. In the demo that we have, we will actually use device provisioning service to be able to provision that. So we can see what it does and how the device provisioning SDKs kind of plays a role there. So as a developer, when I'm a hardcore coding developer, IoT Hub, device provisioning service, all this is great, but how do I write the code? How do I code to it, right? So it gives a lot of SDKs. There are device hub SDKs, there are device provisioning SDKs, and you have other, like especially for Visual Studio Code, you have other custom built extensions that you can associate to it. And if you are to debug it, meaning, hey, I sent something to an IoT Hub, I want to see whether I get those messages. So you have an IoT Hub Explorer for it, which is kind of, I mean, it was a web-based tool, but I have a preview version of desktop tool for Azure IoT Explorer that can actually help us look at all that. So if this is good till now, we can probably go and look at a quick demo. So for the demo, we would have to basically provision an IoT Hub and then a device provisioning service and configure it. So I just want to ask the audience, like, what do you think would be an interesting way to go about it? Do you want to start provisioning it all together, or I also have pre-provisioned ones? I would go through the flow, but instead of clicking the final button, I'll just, yeah. All right. So to create the IoT Hub, first, oh, I thought I was sharing the screen and not the window. Let me just. Okay. On the Teams, I am actually sharing the entire screen. I understand what is happening. Give me a moment. Here, I have to share the screen on the team. Okay. So we are in the create resource blade of the Azure portal. Then let's say you type IoT Hub and create. It's similar to any other past provisioning. So you have a resource group. I have a resource group for Omaha Azure user group, and then there are three basic tiers. One is free, one is basic, and one is standard. Free is like 8,000 messages per month, and then basic is 8,000 messages a day. This is 400,000 messages a day, and premium is, or standard has, in standard you have different limits that you can actually configure. You can go up to 300 million messages Oh yeah, standard is expensive. Like the 300 million messages a day costs $2,350-ish a month. Yeah.
Popular.
In Amazon, you get the highest number of rating for devices that are the more or less the devices that are really, or the products that are really costly. So for now, we will just go with a free trail. Okay, I already have a free one, so I'll just put a basic one. I'm not going to create anyway. And you have both public access as well as a private access that you can configure for it. Meaning, I can have a Azure VPN gateway in front of it and ensure that the traffic comes only from the Azure VPN gateway into the IoT hub. And there are a lot of providers out there who provide satellite connectivity for your IoT devices to be routed via their own VPN. Rignet is one example of it, but there are many such providers who provide you that flexibility so that your IoT data end to end, meaning starting from the device till it reaches the IoT hub, everything is through a virtual private tunnel, right? So we'll go, and this is about the access control that is there on the IoT hub. Whether you want to whether you want just the RBAC or role based one, or you want to have a shared access policy along with rollback, you can configure that, and you can tell what role you would want. This is one interesting facet. So when you are sending device to cloud, right? We assume that I can put an Azure function behind it, which would scale based on the volume that comes in, right? But in reality, uh, if I have two partitions, and let's say I have 3, 4 instances of Azure function running, only 2 are actually going to do the work. The other 2 are going to be idle. To put it the other way around, I don't know how many of you have like worked with Kafka. So Kafka, for instance, I can have a consumer group, but if my number of partitions on Kafka is only 4, and if I have 40 instances on my consumer group, 36 are going to remain idle. Only 4 are going to work. So we will have to judiciously partition the scale based on the volumes that we expect and based on the number of instances that we expect to be processing it. That's the niche item here. And if you want to try new versions of MQTT, I don't want to go in.
Device to
Yes, tier is just for abilities and the number of messages. So 3 million messages, whether I want like on a burst, if I'm going to get 500 messages, if I want it to be consumed by 5 consumers or 10 consumers or 1 consumer, that's what it is.
Is there a max limit?
I haven't tried it yet. I mean, I have put like you can put 10, it will still work, but I haven't like tried more than that. So so I do not know.
I guess this will.
Probably yes. Yes. So they say most IoT hubs need only 4 partitions. Let's see. I like the Defender for IoT Hub is something that I had worked with, wherein you enable Defender as well. So that, I mean, there are 2 flavors. You enable Defender by default, it gives you the basic flavor of Defender. So you get the very basic security alerts or threats that you might have. And you can enable Defender on it, and then you can still go to the Defender and upgrade it to a premium tier, which will actually increase the cost for you here as well. But they don't tell it explicitly, but it will increase the cost for you here as well. And this is for you to be able to provide over the air updates, meaning I install a device and the device has a firmware. I want to upgrade that firmware, right? I need an over the air update. So this ensures that you are able to do all that via your IoT hub itself. You don't want to look out for an external solution to be able to provide an over the air update. So if you want it, you can enable it, otherwise no, and then tags are similar, and then it's basically review and create. And we have a IoT hub created already. So here is that IoT hub. And the interesting thing to look at this is the shared access policies. this is how the security comes into picture. By default, it gives you, or it creates these 5 different policies and with specific permissions onto it. Of course, you can go and tweak it. For example, I will show an example where I have tweaked. I have tweaked these two, right? This was supposed to be just the service connect, which has registry read by it. It doesn't have registry write, but I basically had tweaked. I'll explain why, right? But selecting the correct policy for your usage and providing that is a very crucial aspect. Meaning, for a device to connect, I just have to provide this access policy and the connection string or the key over here. I should not go ahead and provide the IoT Hub owner's primary key to the device. Right? That's the essence of it. Whatever your function is dealing with, you can provide just that enough permissions for that function to be able to operating with the IoT Hub. That is why I just want to touch upon the shared access policy because it is significant. And even if you're doing a POC, if you do not have the correct access policy set, you will not be able to do the operation. You will tell that, hey, requested operation failed because of unauthorized access.
Are these only assigned?
No.
To users or
to any of the services like functions and anything that you are creating. The function in turn would actually use these permissions to interact with the IoT Hub. Like the device connect is typically a key that, for example, in a lot of companies, the hardware team will be separate and we would be separate. So for a device, after authentication, if it just wants to be connected, you can provide this. Or let's say that you have a device client, you can provide this. These are not specific to a device. We will see in the demo how there will be keys, like how the authentication or authorization specific to a device will also happen. The other important point that I wanted to share here is the built-in endpoint. This is what we are actually using. If you see by default, it actually uses just a service bus queue. Right? It actually just behind the scenes, it basically just uses the service bus queue. So if you are having a simulation, connect to this. This is an important aspect that we would have to take and key into our code base, because this is where you are going to actually send the telemetry messages. If you create some other endpoint, you would have a certain way of connecting to it, have a connection string to it, and you would have to plug in that. Right? So if you are to do a POC, knowing the different access policies and the connection string of the endpoint becomes critical for you to be able to successfully connect and send data to the IoT Hub. Now, if we are good till this, I would go to the next step, because in terms of this, all we have seen is just provisioning of the IoT Hub. We are still yet to provision the device provisioning service. So, yes.
Data storage.
Mhm.
We need to define the SQL DB or Cosmos DB, any provision behind screen or no.
You will have to define you will have to define a storage, meaning if you want that data to be stored as is somewhere, then you will have to define a storage. Otherwise, by default, it will be put into the service bus queue. But because it is a queue, once you consume it, it is gone. So
Analytics or
warm path, cold path, and all that. In fact, I don't know about the time, but I do have a demo to actually look at message routing, wherein certain types of messages alone I would actually route to the storage, and we can see how it is like done. Sure, welcome. We will look at provisioning the Azure device provisioning service. So pretty similar. You go in and then you do the same thing. This is like far more simpler because we have seen all this previously, right? So, and then you just go ahead and create it. I already have a device provisioning service created. I will show it, and I will also show you where you would actually be able to link it. Now, this is the device provisioning service that was created. And then here you can see that I have linked it to the IoT hub that I had created. So it will be very simple. If you have one more IoT hub, you like all the IoT hubs that you have will be linked here, and then you will be able to connect to
So
it.
you create a hub, you create a.
Yes. And once you link them, you will have something called as an ID scope. Like this is the endpoint. When you want to provision this is the endpoint that you will use, or you can also use this endpoint. If you use this global endpoint, you need to tell what is the ID scope.
At the device. Device will have.
Yes. Yes. That is one option. Or I can also show you the other way in which the device does not have to worry about all these details. The device actually just calls a URL. It takes care of everything and then returns something to the device,
Maybe
which
you can have an API.
that's what I mean. Typical. That is exactly what I had kind of done. I also have a device simulator to directly connect to, but I thought that it would be better to show it with an API. So now that we have seen these two, the next one is about getting these configurations onto your functions, right? Which is basically nice. Let's just see the local settings, which is basically this, right? You have the connection string for the IoT hub. IoT hub registry is basically where the devices are saved. And when you want to connect to the global endpoint and DPS ID, it is all basically available, right? To speak with the endpoint, you can say I have configured the service bus principal or service bus URL here, right? Now, what we are basically doing here is we have multiple functions. To begin with, we are basically going to enroll the device, right? Let's say that we just want to enroll the device. We are using something called as an asymmetric key encryption for our authentication or security purposes, meaning every device upon provisioning will get its own unique key using which it will be able to make further calls or further transactions to speak with the IoT hub. That is what asymmetric encryption key is. This enroll device function would be able to take a device in and create a key out of it and return that as a response, which will have to be fed into the device. Like imagine you have a device code wherein you call this URL, get the response, you take the key part of it and then put it as part of your connection string, and then you start creating a connection to the IoT hub. That is what this is. And just like with anything, I would actually want to go and comment out the listener for now because we are not going to use it. I'll just run this, show this, and we'll look into that code as to how where the device provisioning service SDKs are used. All right, we'll go here and I'll take this. I'm just going to give a device ID, right? This is just the device ID with which it will be provisioned on the IoT hub. I'm going to send it. Okay. I missed to show that this ID is not there on the hub, but I can like show it now, or we can also create one more. So you can see that I had a key returned to it. And if I go to the Azure hub now and look at the devices, you can see that I have that device ID created.
Where you store the key then? The device.
In this, I have not, but I have a device simulation code in which I actually make that call, get that key, and save that key and use it when I actually send this cloud messages to the device. Because I showed it from a postman, I don't save it anywhere, but here we have that ability. So looking into that code of the device provisioning service, you can see that it basically kind of goes in. You create a asymmetric device key, and then here you can see I get things like the enrollment key. This is the global devicening endpoint, and then this is the DPS ID scope, which we saw in the device provisioning service, right? I take all this, and that's how I kind of create this key. If you want to see where all that lies on the demo.json, you can see all those values here that are related for device provisioning. You have the enrollment key, global endpoint, and DPS ID scope. This is all taken out of the values here in the device provisioning service. So once we have that, now let's see it as a demo, meaning I want to register a new device ID and I want to start sending messages to that device ID. I am going to comment out the receive messages part for now because we have not looked at the C2D communication yet. So as we stated earlier, if I want to look at the messages that I have gotten onto the bus, right? I should be able to look here, right? This is the Azure IoT Hub Explorer, and I should be able to look here. So let's say that I want to look at these messages for dev test 3. That's the one we created recently, right? We go here, we click on start. There are no events received as of yet. Now let's go into the simulation. One good thing is if you already have a device, if you try to re-provision that device, the logic of the code ensures that you don't have any issues because of that. It would still be able to return you a key and you can work with it. So you get disconnected or the device, let's say, gets restarted, right? The firmware gets restarted. You would again try to provision yourself because you do not know at that point whether you are connected or you are even provisioned or not. When that happens, there would be no problems with that. So now I'm going to run this. Hopefully the demo doesn't do anything. Okay, the provisioning is success and you can see it keeps sending message. I have a small delay introduced to send these messages. You can see the type is like varying differently. Oops, not this. You can see that the Azure IoT Hub Explorer is actually receiving the message as and when it is sent. Let's look at it like this here. Right, error information. It is actually refreshing. You can see this timestamp getting updated. You can see that here. Every second or so, you have a new message coming in. And you can see here, like it kind of keeps changing. Information, message, error.
The most latest one is on the top.
It's on the top. When I tried out, I had this similar doubt. That's why for the demo, I actually changed that type at least so that we can see that they are like different ones. So it randomly picks one between message, information, error, and then keeps sending it across on that. So I would stop the observation here for now, but we are able to see that we are able to successfully provision ourselves and send messages to it. I would want to spend just a minute on the code that sends these messages because we want to see how that primary key is used, right? Like you asked that question. So there are multiple ways to get connected to it. One of the simplest ways when we use asymmetric key is basically this parameter. You have the host name, which is like basically the overall connection string would look like oag.devices.net : device ID, which will be that dev test that we said, and the shared access key, which is going to be unique for each device, which means if I use dev test 1 and then try to put the key of dev test 3 here, it is not going to work. It's going to fail. So that's how the security at its very basic level without X509 or anything is being guaranteed. And this connection string is then you have a device client. This is again an SDK feature. You create a device client out of it and then You create a packet and send it. And I just added a delay so that like otherwise it will be too voluminous for us to be able to look at it. So this at its basic is how the device to cloud works. We would also look at the integration of it to Azure services as a demo in like just a couple of more moments, right? Yeah. I would probably skip a few slides and then I would just go directly into the major demo and parts of it, right? Yep. So let's look at the message routing. We spoke about the ability to route messages to storage or anything as needed, right? So for example, all you need to do is just as with any routing, you need a definition and a criteria. A definition is more like an SQL like query expression. We will see that. And then you need to define a criteria. The criteria can be based on the message content, the device property, metadata, on a lot of things. Of late, like in the past 2 years or so, you will also be able to define a criteria based on a property on your device twin or digital twin. That is the other thing that you can actually do now. And you have to have an endpoint where you want these messages to be routed to. So at its basic, you need two things. You need a routing criteria and you need an endpoint. All of that can actually be directly provisioned here. For example, you will have a message routing blade as such. Okay, I'm in device provisioning service. So on the IoT hub, you have a message routing blade and I have configured an endpoint. Ideally, you would have to configure an endpoint here. I have a storage account that I have configured that as an endpoint and my route criteria. You can see my query. I am telling in my body, if the value of T is error, then route it to this storage endpoint. That is what I'm telling. And we did actually send a bunch of messages. I'm pretty sure there would have been 1 or 2 error messages there. Exactly. For errors alone, the reason why I was using it is like, if there is a message which is an error or which needs special attention, I route it to a different place. You can actually route it to a Cosmos DB or few other places. For simplistic purposes, I just routed it into a storage. If it is an error, I want to route it into a storage and then I can actually observe that specifically.
These devices keeps.
Exactly. That's why the routing is even in there. And when I send, I actually tell what is the name of how I want it. You can see I tell the sub partition and then year, month, date, hour, and then I give that as a JSON, right? So you can see what are the other different endpoints that are available here. To your point, if I want to process something differently, I can route it to a service bus queue or a service bus topic, and I can have a listener for that to function it in to process it in an entirely different way. So
Not like you can just have one store.
you can have multiple endpoints. What I don't know on that is though, can I route the same message to 2 different endpoints? That is something that I have not tried, but I think that will be interesting to try. I don't think it is possible because yep. Yeah, and I don't think it is possible because behind the scenes it is a service bus queue, and I believe yeah, if I hope they would typically have used they wouldn't have used a P clock mode, they would have used a delete mode, like read and delete mode, because otherwise it's going to stay on that and it will be a problem. Yeah, it could have been a basic queue. True, it could have been a very basic queue. So we don't know. That will be a good one to try.
It goes to storage and the Cosmos DB.
Yeah.
Later you compare these two and say, hey, you know what? Some message here. In case something.
Yeah, there might be workflows where you might have to deal with a message in 2 different ways.
Absolutely. Yep.
There are subscribers on topics.
Yeah, that's what I'm saying.
Mm.
In service bus, he's saying it behind the scenes, it's a service bus. So assumption is it would be plain vanilla queue,
Queue.
not the topic implementation. So if it's topic, then you can have
Multiple subscribers to it. Yes, it might be just a queue.
It's as soon as first
It's gone.
it's
I saw a topic over there. Service.
on custom endpoints.
Here.
So there you go.
Yeah. Then we can route it to a service bus topic from where you can have different subscriptions out of it, and then you can run it different ways. Yep. So power of collective thinking. So now we saw that we have not yet seen the messages being routed to, but because we already seen some of the messages, I'll just go into the storage queue and I would look at the storage browser. Let's hope that we have some messages for today's date. I hope it will be 01/2023 7. Today is 20. I mean, it's 19, but it's in UTC, so 20. And in that, you can see I'll have to download this to show, but that's pretty simple. Yeah. Seriously. Where is Notepad++ easiest one to? Just Notepad. So anything that was error alone should have kind of come here. It's the total. You can see it's only the error messages that has kind of been routed here. We had messages, information and error. Only the error messages are kind of routed into this as a JSON. So that's the advantage of message routing. I know we are short on time, just 10 more minutes. So what we could do is we could then directly go and look at the integration to an Azure service. I mean, theory is good to know, but it's always the demo that I think would be more interesting, or like how do we actually do that stuff, right? As you can see, these are all more theory. So after message routing, this is the demo that we just saw. And event processing is, again, you basically have a trigger and you have a subscription, or you can either have a trigger or you can have a subscription, meaning simple use case would be what we call a storage queue trigger or IoT hub trigger. Behind the scenes is basically a subscription. You poll that endpoint. But that same workflow, if you pivot it as from the storage, from the Azure storage Azure, from the Azure storage or from the IoT hub, if I click on the events tab and if I send that event to a event grid, which in turn pushes it to my storage, then that's an event trigger, right? So you have both those ways by which you can have or process events in the IoT hub. And for the demo, let's just create a IoT hub trigger subscription function, and we will consume those messages as they arrive. So as you see, I first commented out that part of the code. What I am doing here is basically I use an IoT hub trigger. Again, this is an attribute given by the SDK. So I tell to this IoT hub trigger that on the messages/events route, listen to those events for the event hub connection that is defined in my connection app setting, right? If you want to see what is the event that is defined in the event hub connection app setting, you can see that it's the service bus endpoint, right? Basically, I'm listening to that service bus endpoint at its core. That's all that I'm doing here. And for simplistic purposes, I'm just getting it and I'm just storing, like I'm just writing it out onto a console. So for me to be able to run this, I would have to first run it with this. But I think what will happen is the moment I run those older messages that were published, right? It might be consumed. A lot of times in local, whenever the runtime starts, it will actually consume those messages. But we only sent a few messages, so we should be good. So it has consumed those messages. Now let's send more messages to it. This is the device simulator. So this is kind of the device. You can see what happens. It comes in and then you can see that it is being picked. it will be,
It's reading from the service bus.
it's reading from the service bus, and it will be almost near instantaneous. These two would be, again, I mean, the reason why it is say near instantaneous is because though both these applications are in my local, in reality, it is connecting to a hub on the cloud, and this is reading from the service bus on the cloud, and still it will be like pretty fast. There wouldn't be too much of a latency. And let's try to stop it here, and then we should see that being stopped here as well. At its base, this is how I can read those messages from service bus into this. Last but not least, one another interesting factor that we would want to check is, hey, whether I'm able to receive messages onto the device, right? So I'm going to go directly into it, into that reception now. I just wanted to ensure that all these demos, we are able to look at it. So in the device client, for receive message, all I am doing is basically, I'm creating a listener for it. From the device client, I'm basically creating a listener for it, and I'm waiting to see if there are any messages that come in. And once I get a message, I just kind of print it out and I complete that message, right? There are multiple modes here. I would talk to it, but in the demo, it is not all. Like you can tell on the IoT Hub, the cloud to device message is very interesting because you have multiple methods of connecting to it. You can connect to it in an asynchronous way. You can connect to it in a synchronous way. When you connect to it in an asynchronous way, there again you can tell whether I need an acknowledgement for this asynchronous one or I don't need an acknowledgement for the asynchronous one, which means I would send a message. I would not wait for a response immediately, but I wouldn't clear the message from my queue either. I would wait for an acknowledgement from the device, only then I would clear the message from the queue. This is option 2. First option is I send a message, I clear it from the queue. I don't care whether the device got it or not. The third option is, that's more tricky. It's not asynchronous at all in nature. You send a message directly to the device, invoking a function on the device, invoking a specific function on the device, and you wait for a response from it asynchronously. And there is a slide on the best practice, but lack of time, I'll tell it now. The suggested best practice from Microsoft is going asynchronous when your D2C is much greater than your C2D. In most cases, that will be the case, right? The device will keep sending telemetry. You might send 1 or 2 commands at the very end. But we had a special use case wherein, because of the way that we had been using IoT even before the advent of IoT Hub and everything, for every D2C, there will be a C2D acknowledgement for it. So in our case, what happens is our C2D is actually greater than D2C because my C2D equal to D2C plus the other commands that the users are going to send. So the suggestion from Microsoft was, when you have this high level of messaging going back and forth between, it is better to use a direct method. So we ended up using a direct method for it, and yes, it is synchronous. So there are some more, so which means that we will have to parallelize it on the invoking to the direct method, and I cannot like do that call asynchronously. Right. So now we will see here the device has a receive messages function as well. We will try to just see if I can receive those messages. And again, I'm going to take the help of Azure IoT Hub Explorer to kind of send it.
You don't need to change any configuration to enable device to receive. Very provisioned, it's all done.
It's all done.
Because it could be one direction, it could be bi-directional.
Correct. In reality, like this, if you see the code, it just says receive async, right? In reality, what the receive async would have done is it would have subscribed to a topic behind the scenes in the service bus. On the publish, it would have actually posted to a topic. Messages/events, if you see, is the topic where it actually posts it. But for reception, it would actually subscribe to a different topic to actually get the messages from. And the topic name will actually have the device ID in it. So that's the backgrounds of it. So the connectivity is still the same, but for publish, you are using to publish to a topic, and for reception, you are actually getting it from a subscription. So here, I should have probably saved that, but okay. Good that we have it here. I will like copy it. Hopefully I have something here. Okay, I'll copy this one. I'm going to send this. It says it has sent, and you can see I'm able to receive it here. So I'm able to send and I'm able to receive it. We can also do that in tandem. Like if I enable both these functions, you can see that it will keep sending, and in parallel, when you push, it will actually receive. I mean, that's also simplistic. I can kind of show that, because that will like, that is kind of simulating a real device scenario.
Is there any from the size of the message?
Yes, there is 4 KB. That is determined by the IoT Hub. The size of the message is to be 4 KB. And there are a few more limitations as well. I will like tell. I sent a receive, and then you can see there is a receive message here, right? There is one receive message here. So as it sends also, it will still be able to receive and work on it successfully. There is no problems with that. And to your point, there is a 4 KB limitation on the size of the message, and there is a limitation on the number of messages as well. But it is not a math, meaning 100 messages class 4 KB, 4000 KB. So can I send 2000 messages worth 2 KB each? No. Your limit is also on the messages, and per message the limit is also on the 4 KB. But taking device into a consideration, mostly it wouldn't be that heavy. You can see like this is the JSON I was trying to kind of send it across to our hardware team. I first created a well-defined JSON, and then they said, remove all characters, alphabets, just give me one. That's it. Because our packet size is, with header, checksum, everything, it's like 40 to 40 bytes. That's all the packet sizes. So though we receive 5 million messages a day, we wouldn't even exceed a GB of data in terms of that. Because again, we have our own custom protocol, custom defined format. Each bit of that protocol has a different meaning.
It also adds to your regress cost.
Absolutely, yes. That's the most important part, because in ours, we were using cellular connectivity. We still use a cellular connectivity, and the SIM is provided by us. So if I provide it to you, for your egress, I'm going to pay, right? Of course, you will pay me a subscription cost, but I'm going to pay for it. So if your data size is high, if I provision the data size to be high for 4 million messages, if I just increase that size by like, if I just double the size, it would be approximately like a $500,000 extra bill.
Same as
Sorry.
Azure, right? Saying that you're sending back acknowledgement.
Absolutely, yes. They are all egress.
Regress cost as well.
Absolutely, yes. In fact, like to just give things into context, we have a 30-minute sending, right? We were asked like, hey, what happens if we try to pivot to see what happens if we decrease that from, instead of 30 minutes frequency, what happens if I decrease it to 10 minutes frequency or 5 minutes frequency? We just did a rough math. Our mobile bills were like up by 1.5 million a year. Again, it seems sense when you look at it as one, but because of the volumes, it has a significant difference.
Is the same for C2B and D2C limits?
Yes, the message limit is the same for C2D and D2C, but on the C2D, you have a challenge. If your device is sleeping, if your device is totally idle, the queue can accept, at least on a service bus, the queue can accept up to 50 messages. Once there are 50 messages enqueued into it, if you try to push a message into it, that itself will error out. You cannot even push a message into the queue after that until you have like cleared this queue. So if you want to do error handling, I can just show that just as a sample. That is where those device connects and all that comes into picture. Again, this is a method to remove the device, but it's okay. We don't want to get into that. If you go here, if you see what I do is when I receive a, when I wait a minute, when I receive a message or when I am going to send a message to the device, I actually go to the registry manager and I check what is the number of pending messages that are there on the queue. And if the count is greater than a certain number that I had set it at 30 or 40, I actually clear the device message queue. Because otherwise I'm going to get an exception right when I'm actually enqueuing it. Again, this is case to case specific. You can also allow it to error out and then have a triggers out of that errors. In our case, we were okay to kind of delete it because we have redundancies built into our systems wherein I send a packet. If the device does not receive it, the server knows that I have not yet got an acknowledgement from the device, so it will keep resending it again and again. So I am okay to clear the device queue, but it is on use case to use case basis.
Why there is a limit?
Well, at the end of the day, you are actually using just a service bus queue. On an if you instantiate a service bus queue, like forget about IoT Hub. If you instantiate a service bus queue, it has a limit on the data size. You can have, I think, only up to 10 GB of data or something on the service bus queue. Now, you do not know how many devices you are going to connect to. They have a very rough math of, let's say you are connecting 10,000 devices at a time. Then if I put 50 messages at a time onto it, I will still not exceed the capacity of service bus. This is my guess as to why
50 messages
per device. So yeah, if you have 10,000 devices, for each device you can have 50, 50, 50, 50, 50. Right? So it's like 500,000.
Something had changed in service bus that I didn't know.
No, it's per device. Yep. And again, the last part is the logical deduction of it. I haven't seen the documentation as is about why it is 50, but that's kind of more a logical deduction of why it would be 50.
Per device message.
Yep, it is per device. Yep. All right, so that is it about the demos, but we saw about security authentication. We already saw it, but there is more to it. You have threat monitoring, you have firewall and network security. We spoke about it. In our solution, for instance, we actually have that security end to end. Right from the device till our servers, we actually have it completely via VPNs. And I'll just take 1 minute for this Azure Edge integration. I don't have a demo either. Azure Edge integration is about, think of it like a proxy for some think of it as a server's proxy for a limited set of capabilities on an edge device. Meaning, let's say you have a device, you want to do some computations, you want to have some form of calculations that are being run on that device data. You don't have to necessarily reach the server, but you reach an intermediate point, which is an edge device, in which you would be able to run that computation and return immediately, right? So even if you are offline to the server, as long as you are able to connect to this edge device, you can still have that small computations run. I as a developer or a company is going to provide those edge capability as well. They are called as edge modules. Basically, they are just Linux container codes, just Linux containers in which you have some function, some calculation, some code that are running. But because it is integrated with Azure, you can leverage Azure's services for you to kind of work on a miniature level. That is what Azure Edge is. It basically consists of just 3 modules, which is the code that you write, runtime, which is what Azure provides so that it can take care of monitoring, controlling, and doing all that. And the third one is basically the interface to handle all that. So this is about the edge modules and the runtime. You can see, these are the different modules. Like you can have a telemetry.
Have IoT Edge installed on Azure Stack.
Yes, you can. This is the same. Just like how you have you can have edge provisioning service install some edge devices. You can have specific IoT specific devices so that you'll be able to install Linux container based IoT edge modules over it. I mean, at the end, it's like function and logic apps. You take the same base and you like pivot it into different flavors, abstract and pivot into different flavors, and you provide it. So that is about the IoT edge module. And for monitoring and diagnostics, you have all alerts and notifications that you can configure, just like how you would configure in any PaaS service. You have complete integration into Azure Monitor and application insights. So you will be able to dump logs into it, debug into it. You can enable whatever you can do in a PaaS service. All that is available here. Along with it, you have device monitoring and message monitoring that are specific to IoT Hub. On the metrics plate, you can see that you have the latency when you route, what is the latency for routing and all that are different monitors that are enabled. And in terms of best practices, do not use an asymmetric key operation, asymmetric key authentication when you are going large scale, full scale. We are still in a pivot mode for our IoT. We are like 40 on 100,000 devices. So, but when you go for an actual one, it is better to use an X509 certificate. And you will have to do an auto provisioning for this is kind of an auto provisioning, but in this you could see that I have a few things hard coded and I just get a symmetric key out of it, right? You can actually do an end-to-end auto provisioning as well, but there are some work that has to be done on the manufacturer level, some has to be done on the IoT level, and some at the developer level. At the end, I have actually thrown in the slides for that alone as to what and how it has to be done. What is the role for a manufacturer, device operator, and the developer? But I don't think we will have time to get into. But if interested, you can always have a look at that. And keep your messages small because it is IoT. The point I spoke about symmetry and asymmetry of C2D and D2C messages is what is mentioned there. You can do an async method or a direct method. Because it is IoT, ensure we have enough error handling and retry policies on it. Device can be down anytime. Your IoT hub might not be able to send it. So, or the device, when it tries to connect to the IoT hub, it should also have enough redundancy and retry policies to be able to send it. As with any multi-serviced environment, have enough observability, monitoring, and analytics on it. And especially when you go to, like for us, when we have to go to Europe or something, be aware of the data governance and compliance, GDPR, and all that. So I know I had to rush through quite a few towards the
Great
end,
stuff.
but any questions?
What is IoT Central? What is it?
Okay, so IoT Central is more of a centralized IoT hub is, you can see the device provisioning services separate. IoT Edge, for IoT Edge, you have only a few capabilities in the IoT hub as is. IoT Central is kind of unifying your IoT hub and your edge capabilities, all that into one central plane. So you would be able to tell, hey, I want to install these edge modules and these devices would tie to this edge module. That is IoT Central. I had only seen and like worked on it at a very basic POC level, but
Is it
that
just a centralized dashboard, or is it a service on its own?
it's a service on its own, but it is not just dashboard, but you have a UI that actually unifies all these together. Like you have
Rather than going configuring IoT hub separately and separately, I can go and do all those things.
Yes, you would be able to do that in IoT Central. Where I used it more was about after I had configured IoT Hub for installing Edge, I tried to use IoT Central and play around with it. But in reality, I have not used it in a production scenario or something.
One more question. You have shown all the integration with Azure services, right?
Mhm.
So can we integrate it with other third-party services?
I don't see a reason why you cannot do that. You should absolutely be able to do it. Meaning,
For Azure services, it is so well integrated, right?
correct.
You can just go and provide endpoints to Event Hub and Service Bus and whatnot.
Yes.
I don't know how easy it is to go and let's say I might have a different data storage somewhere else outside of that.
I think probably you might have to leverage some. I mean, easier option might be to leverage some of the inbuilt like Azure function.
Hypothetical because it makes sense to keep all that data there itself.
Yeah, but I mean, the question is very valid, right? Like for our use case, we were also contemplating, hey, I get all these readings. Why not put it into Kafka? Because I have like umpteen services that are running out of Kafka, right? So if I use IoT Hub, I get all this. It makes every sense for me to actually route it to a Kafka instead to any of these services alone. I just don't know whether I can directly route it to Kafka, but what I do know is that I can have a consumer, Azure function consumer that can actually send it to Kafka. That is, but you have one extra hop and it is better to avoid that. One extra hop, one extra log to kind of debug. So yeah. So you can use Azure Data Factory whenever you want to do, let's say, a database to database extraction, transformation, and storing it. We have two different applications, but one application needs the data from another application. So what we did was we had a data factory in between. It takes the data from this application, creates it and puts it into a database, which will be accessed by multiple other applications. But when I extract it, I transform it into a structure that is more needed for the other services that are consuming it, and I put it. I extract it from a MySQL server and I put it into an MS SQL server and I kind of drive it. Now, this was done like some 5 years back, so I don't know why from MySQL to MS SQL. What's the great deal? But that's and Azure Data Factory is costly. That's my feel on it. I feel it is costly, especially if we configure it to run like 30 minutes once or 1 minute once, because it costs for the amount of data I transfer, number of runs. It gets
I think
costly.
it's cheating.
Which yeah, very true.
You have to see the value.
Yeah, I don't have to write any integrator.
That good stuff. Thanks.
Sure. Thank you. Thanks for patiently listening. Thank you so much.